All right, let's get started. See, in the last class, we were in the middle of problem sheet number 7, and then we also started a new topic, right? So this was an easy sheet, but we did not complete the discussions. So let's complete the discussion, and then we'll go to the topic we discussed in the last class, that is unique solution, infinite solution, no solution case. Okay. So we were on question number 4. Remember, we were on question number 4. We have to do 5 onwards. Okay, so let's go to question number 5. Yes, question number 5. Find the value of c such that x is equal to 2 is a solution to the equation x by c is equal to 3. See, if you come across a question, you don't have to even move your pencil. You don't have to move your pen. You don't have to pick up calculator. You can do mental math, right? Right? What is the answer? What is the answer? What is the answer? See, in this question, x is a solution, c is a constant. You have to find the value of constant. X value is given. X value is given to be 2. So what is the value of c? What is the value of c? What is the value of c? Please tell me. Please tell me. We are on problem number 5 from the previous sheet. Yes. As easy as that, right? X by c is given as 3. And your x value is given to be 2. Okay. 2 by c is equal to 3. So your c is equal to 2 by 3. Do not get tempted to write 6, okay? Do not get tempted and write 6. Cool. This was question number 5. All right. Let's go to the next question. That is question number 6. For what value of c do the equations 2y minus 5 is equal to 15 and cy minus 8 is equal to 36 have the solution for y? Okay. So when you have 2 equations and they are connected by and, okay, this means that this is what we call a system of equations. This is what we call a system of equations. Okay. And in a system of linear equations, you are actually looking at the common solution. So if you're finding out a value for the unknown variable y, it should satisfy both the equation. Okay, that is the idea. The idea is if you have a system of linear equations, the value of the unknown variable you find out should be same for both the equations, which means the unknown value should satisfy both the equations. It should satisfy both the equations, right? That is the idea. Got it? System of linear equations. We'll see more system of linear equations when we study linear equations in 2 variables. You've already seen, right? System of linear equations is 2 variables. Do you remember this from school? From the school? Do you remember the system of linear equations in 2 variables? 2 variables. You will have both x and y. and then you will have two equations. Do you remember? What about others? Do you remember system of linear equations from school? Yes. That is when you have two variables. Okay, we have only just one variable here. We have just one variable here. So usually we never have a system of linear equations when you have just one variable. But in this case, there is an unknown parameter. There is an unknown constant given in the question. So to evaluate that parameter, to evaluate that constant, first of all, we can solve this equation. We have 2y minus 5 is equal to 17. From that, we can find the value of y. And now you can substitute the value of y here. And from that, you'll get the value of c. You understand the logic? From the first equation, solve the value of y, evaluate the value of y, get the value of y, and then substitute that in the second equation. Then you will get the value of c, right? Am I right? So what do we have here? In question number 6, we have 2y minus 5 is equal to 17. And the next equation is cy minus 8 is equal to 36. And what am I going to do? I'm going to solve the first equation. So 2y is equal to 5 plus 17, which is 22. Now y is equal to 22 by 2, which is 11. Right? Now what will I do? This value of y, I'm going to substitute here. So we have 11c minus 8 is equal to 36. So 11c is equal to 36 plus 8, which is 44. So your c values 44 divided by 11, that is equal to 4. All right. This is fine. Tell me, please tell me. Please tell me whether it's okay. If it's okay for you, yes. Others? Yes, question number 7. Again, if b is equal to 5 is a solution to the equation, find the value of k. So we have question number 7. B is equal to 5 is a solution to the equation 10b plus b plus 3 equals 11b plus k. Yes. Okay, listen carefully. Let's do it in the straightforward manner, and I'll also give you a shortcut. I'll also give you a shortcut in this question. Okay, listen carefully. So b is equal to 5, right? So I'm going to substitute b is equal to 5 here. So this becomes 10 into 5 plus this becomes 5 plus 3 is equal to this becomes 11 into 5 plus k. So this becomes 50 plus 8 is equal to 55 plus k. So this becomes 58 is equal to 55 plus k. Now your k value is 58 minus 55, that is equal to 3. Easy, right? Easy, right? Tell me. Yes, others? Yeah. But is this how you have done? Is this how you did this question? Is this how you did this question? Is this how you did this question? Yes. But there is an easier way. See, if you listen, if you observe carefully, see this. On the LHS, on the RHS, we have 11B. In the LHS, we have 10B plus B. So that is essentially 11B itself. And that is going to go away. So 11B and 11B, 11 times B, 11 times B is going to go away. They are going to get cancelled. So just by looking at the question, just by observing, you have the answer. 3 has to be equal to k. 3 has to be equal to k, or k has to be equal to 3. Do you observe that? Do you observe this? Tell me. Is this confusing? No, it's easier, right? It's easier, right? It's easier, much easier. It's much easier. See, if you can observe things and if you can do some amount of mental math, right, you can save a lot of time. You can save a lot of time. That's the idea. Yes, let's go to the next question. Question number 8. X is equal to 10 is a solution to the equation 2x minus 5 is equal to 5 in k into x minus 5. X is equal to 10 is a solution to the equation 2x minus 5 is equal to k into x minus 5. Then the value of k is. Okay. We have 2x minus 5 is equal to k into x minus 5. And x is equal to 10 is given to be a solution to the equation. X is equal to 10 is given to be a solution to the equation. Now, let's go and substitute 10. We have 2 into 10 minus 5 is equal to k times 10 minus 5. This is equal to 20 minus 5, the LHS. And RHS is k times 5, which is 5k. On the RHS, we have 50. Sorry, LHS. And the RHS is 5k. So your k is nothing but 15 divided by 5 equal to 3. Yes, got it? See, I request you to actually try out this problem before coming to the class. Okay, you can't really learn to do the questions by watching me do the questions. Okay, so you have to actually try it out. give it some time. That is the way to do math. We have to do it the hard way. There's no shortcut. Got it? I hope we have already solved this question. Right? Yes. Yes. We'll go to the next question. Question number 9. N times 4x plus 8 is equal to m times 5x plus 8, and x is equal to 8 as its solution. Then the value of m by n. Of course, there are two unknown constants here. There are two constants, m and n, but they have not asked for the individual values of m and n. They just need m by n values. So it is possible to get that from here. Okay, just go and substitute 8 in the expression for x. So we have n times 4 into 8 is 32 plus 8. That is equal to m into 5 into 8 is 40 plus 8. So n times 40 is equal to m times 48. So your m by n value is going to be 40 divided by 48. 40 divided by 48. 40 divided by 48. The answer will be? The answer will be? You just cancel of 8 on both sides. So here we have 5 times 8, 40. We have 6 times 8, 48. So the answer is 5 divided by 6. 5 divided by 6. 5 divided by 6. Got it? Yes or no? Yes or no? Yes or no? Yes or no? Yes. But if you observe carefully, if you observe carefully, you can get rid of 8 in the first step itself. Can you see that? Can you see that? You can get rid of 8 in the first step itself. If you can see that, say yes. If you can see that, say yes. I'll show you how to do it, but I want you to observe it. If you can see that you can get rid of 8 in the first step itself. Tell me yes or no. Just tell me yes or no. I just want to know. That's all. See, do not hesitate to tell yes or no, okay? Because we are not judging here. We are just learning stuff, okay? So we are just learning things. So it's absolutely okay to say no if you don't get it. No problems at all. So in the first step, you can see that from both LHS and RHS, an 8 can come out. So we have n times. If you take an 8 outside, if you take an 8 outside, so this is going to be 8 times 4 plus 1. You get that? And on the RHS, an 8 can come out and it will be 5 times plus 5 plus 1. Sorry. Yes. So 8 gets cancelled right away. 8 gets cancelled on both sides. And you're ready with the answer. That's pretty cool, right? So your m by n will be, as usual, it is going to be 5 divided by 6. This is 4 plus 1 and this is 5 plus 1. Got it? Got it? Yeah. So in an SAT, even if you save 5 seconds, it's worth it. Even if you say 5 seconds in a question, sometimes you will be able to save 10 or 20 seconds in a question if you have had enough practice, if you can figure out stuff very quickly. You get my point? Yes, cool. Now the question number 10. Question number 10. In the equation, 3 is equal to mx plus 5. M is a constant. M is a constant. X is equal to minus 2 is a solution. What is the value of M? So we have 3 is equal to mx plus 5. M is a constant. And x is equal to minus 2 is a solution. Listen, these are the question. These are real SAT type questions, okay? Okay, these questions, these type of questions do come for an SAT. These are pretty easy questions. But the trick is about solving it in a few seconds. Okay, because you have to solve 58 questions in 80 minutes. You hardly get a minute to solve a question. So if you can solve some of the questions in maybe 10 or 20 seconds, you could save up the time and use it up for some difficult questions, which might take 2 or 3 minutes, right? So that's the idea. Yes. See, our idea is to get an 800. Okay. Get a perfect score in mathematics because it's possible. No, the questions are all pretty straightforward. They are predictable. Okay. If only thing you need is some good amount of practice, and during the exam you should be able to observe things. See, you may not get the same numbers in the question. You may have different numbers, okay, but you'll get same type of questions. If your basic concepts are clear, you will be able to crack it. That's the idea. It's not like mechanically doing stuff. You memorize something, go to the exam and reproduce. Not that, it's not how it works. You understand the basic ideas, and apart from that, I'm teaching you some of the shortcuts, okay, and use it over and over again. When you do a problem on your own, always try to look for shortcuts, sneaky ways, okay. So the idea is to save as much time as possible. Now let's go to this question. So just you have to find the value of m. So without moving your pen and paper or without picking the calculator, can you tell me the answer? Just try to do the mental math here. It's not a difficult question. Can you solve this question? without Do not take your pen and paper, do not pick up your calculator, just by doing mental math. Can you tell me what the answer? I hope you have already solved this question previously. Little more careful, Olivia. Just be a little more careful. Yes, okay, cool. What about Robin and Trisha? Take your time, no issues, because initially it will take some time. It will be frustrating, but as you practice more and more, you'll be able to do it quickly. Yes, the answer is 1. Just do it mentally. Substitute x is equal to -2. So you have 3 is equal to -2m plus 5. Bring 5 to the other side. We have 3 minus 5, which is -2. So you have -2 is equal to -2m. -2 gets cancelled on both sides. You are left with m is equal to 1. Tell me. Whether you're able to do this mentally. Yes, Prisha. What about Prisha? Okay. Yeah, it's 1. See, you can't always rely on mental math. But the idea is whenever you can save time, you should be able to use mental math and save time, right? You can't always use mental math, because long sums and all, you might end up making mistakes. Between making mistakes and saving time, okay, see, if you make mistake, gone, everything is gone. So if you think there's a possibility of making mistake, do not resort to mental math. Just pick up your pen and paper. Okay, so in this case, we have 3 is equal to m into -2 plus 5. 5 goes to the other side. We have 3 minus 5 is equal to m times -2. Okay, let's just write m times -2 itself. So we have -2 is equal to -2 times m. So your -2 gets cancelled on both sides. You're left with 1 is equal to m. Everyone, please reproduce these steps in your minds. Please reproduce these steps in your mind. Just don't look at the steps, but starting from the first step, just try to do this. Just try to visualize this in your mind. It's possible, right? It's possible to do in mind, right? Yes. Okay. Cool. Basically, do you guys use calculator throughout your school exams and schoolwork? For your entire schoolwork, do you use calculator? You always use calculator? Not always. Okay, then it's fine. Because you should not be too much dependent on calculators, because there'll be a disadvantage. We may not have that kind of a type. Yes. So we're done with problem sheet number 7. So we were in the middle of discussing the next topic, which was dealing with a general linear equation. Okay. and we saw that there are 3 cases happening. Do you remember? By the way, can you tell me how many questions you were able to solve out of this 10? You can just message me personally, no issues, to the device which is muted. I'm speaking from my iPad. I'm looking at your chat from my Mac. So just if you want me to message personally, message me to the one that is muted. How many questions you were able to do? How many questions you were able to do? Please let me know. Please do let me know. See, we are not judging here. We are just learning things. So it is okay to make mistakes. It is okay. Yes, please tell me. Please tell me how many questions were you able to do out of this 10? See, this is the only tricky part that you'll be seeing in this section. We're discussing linear equations in one variable. We are discussing linear equations in one variable. This is the tricky part. Okay. The only tricky part. But questions will come from this part. Okay. Please respond. Please respond. I'm waiting for an answer. Even if it's a very small number, it's okay. But I would like to get an answer from you. Please do let me know. 2 persons have replied. Olivia, can you just let me know the answer? I mean, how many questions were you able to crack? Olivia, can you please respond? Hello, are you with me? Yeah, you were able to complete. I mean, I would like to know the number of questions you were able to crack from the sheet. Number of questions. The number of questions. We're talking about problem sheet number 8. Okay. Okay. Cool. Okay. So I'll just quickly have a recap. See, when you're given a linear equation, see, a linear equation will always look like this. When you simplify the LHS and RHS after expanding the brackets and after combining the like terms, a linear expression will always look like ax plus b equal to cx plus d. What does that mean? You have a linear expression on LHS and you have a linear expression on RHS, right? Of course, you can't have quadratic expressions on both LHS and RHS or either side, right? So on both LHS and RHS, we will have linear expression, and we know that a linear expression will always be of the form ax plus b or cx plus d, or you can say mx plus c, or you can say a0 plus a1x, or you can say alpha plus beta x, right? You would have already learnt about linear functions also. In the next section of this hut of linear algebra, we will go to linear functions. Have you heard of linear functions? Linear functions. You've heard of functions, right? Functions. Tell me, from school, you've heard of linear functions? Right. So we'll soon see that as well. Okay. For the time being, we're discussing about linear expressions, okay, and linear equations. A linear expression will be of this form, this form, this form, this form. Okay. A linear equation will have an equality. A linear equation will have an equal sign. You can either zero on one side, or you can have another linear expression on the other side, right? That is a linear equation in one variable. And when you have a linear function, a linear function will look like this. Say f of x is equal to ax plus b. You basically feed x to the function and it will give you ax plus b. That is about linear functions. It basically has an input and the output will be a linear function, a linear expression of x in x. So that's the idea about linear functions. We'll come to that soon. Okay. Now we are discussing linear equations. In a linear equation, you will encounter linear expressions and you will also find an equality sign. On either side of the equality sign, you can have linear expressions on both sides, or you could have just zero on one side. That is also possible. Because in the next step, you're going to bring everything to one side. Okay. So it is not necessarily to have a linear equation on one side. You can also have zero, right? Anyway, so this is the general equation that you will often encounter. And we have three different possibilities here. We have different possibilities here. For example, the first case is a not equal to c. A not equal to c. In this case, say take a specific example. Say 2x plus 5 is equal to 3x plus 8. Here, these two numbers are different. This number and this number are different. In that case, it will have a unique solution. It will have a unique solution. Why? Because you bring 2x to the other side, 8 to this side. We have 5 minus 8 is equal to 3x minus 2x, which is x. We have minus 3 is equal to x. We have a unique solution. Right? So what is the condition for unique solution? The coefficient of x on both sides must not be equal. Okay. Coefficient of x on both sides must not be equal. Right? We are not saying anything about the constants. The constant may be equal or may not be equal. The constant may be equal or may not be equal. Right? For example, if you have 2x plus 5 is equal to 3x plus 5. Suppose the constant is equal. What is the solution in this case? Tell me what is the solution in this case? Can you tell me what is the solution in this case? What is the solution in this case? We have 2x plus 5 is equal to 3x plus 5. What is the value of x? Please tell me. What is the value of x? Yeah. What about others? 0. 0 is the answer, right? Because, without thinking twice, you can cancel a 5 and you're left with x is equal to 0. Okay. It is still a unique solution. Okay. It still has a unique solution. And the solution is nothing but 0, right? The solution is nothing but 0, but it is what we call a unique solution. There is just one single value. There is just a single value of x which will satisfy the given equation. There is just a single value of x that will satisfy the equation, right? So this part is clear. So far, so good. Right? So far, so good. The first case is clear. The first case is clear. First case is clear. The first case is clear. See, I want you to know this stuff, okay? Because, in school, you may not have directly learned the steps, the algorithm. You may not have actually learned this in school, but you would have seen such questions. You would have seen such questions because, in your textbook, such questions are there. And in SAT, these are common questions. But I don't think you would have learned this kind of 3 steps. So it is important to understand these. You get me? Yes. So let's go to the next case. Next case is when A is equal to C, the coefficients are equal. The coefficients are equal, but the constants are not equal. The coefficients are equal and the constants are not equal. Say, for example, we have 2x plus 3 is equal to 2x plus 5. What happens here? What happens here? What happens here? In this case, what happens? What happens in this case? Tell me. What is the situation? What is the scenario in this case? Just think, when A is equal to C and B is not equal to D, what happens to this question? Please do respond. Yes. What about others? What about others? Please tell me. See, you have to be crystal clear with this idea. Okay, so you know what happens? When the coefficients of x are same on both sides, what happens to the equation? These two terms become the exact. These two terms becomes exactly the same. So that is getting cancelled. And now in your case, your B is not equal to D. So these two are not equal. So you have 3 is equal to 5. Which doesn't make sense, right? So irrespective of the value of x you choose, this is not going to get satisfied for any value of x. For any value of x, this equation will not be satisfied. Right? There's a big damage here. This cannot be repaired. See, to begin with, the equation has a contradictory term. Why? Because 2x and 2x gets cancelled. You're left with 3 is equal to 5. That will not happen. Yes. So here we say this has no solution. No solution. Cool. This is cool. Yes. Tell me yes. Yes. And in the third case, when you have the coefficients equal and the constants are also equal. Say for example, we have 2x plus 3 is equal to 2x plus 3. What happens now? What happens now? Yes, infinite solution, because the expressions on both LHS and RHS are identical. The expressions on both LHS and RHS are identical. They are exactly the same. So irrespective of the value of x you substitute, it is going to be satisfied always. It will be always true. It will always be true. Okay? Irrespective of the value of x, it will always be true because, the expressions on both LHS and RHS are identical. That's fine. Right? Right? Yes, cool. Now, shall we go to the questions quickly? Others. So these three cases are clear, right? Now let's see the questions. See, first question. Question number 1. We have 4x plus lambda divided by 2 is equal to 2x plus 8. Okay, listen carefully. Listen carefully. Question says the equation has infinitely many solutions. Infinitely many solutions. So what are we looking at? We are looking at identical expressions on both LHS and RHS. We are looking at identical expressions on both sides, both LHS and RHS. So there are two ways to think about it. You either distribute this 2 in the denominator to the 2 terms in the numerator. So this can be written as 4x by 2 plus lambda by 2. That is equal to 2x plus 8. This is fine. Right? So 4x by 2 is going to be 2x. 2x plus lambda by 2 is equal to 2x plus 8. Now for this equation to have infinitely many solutions, the expressions on both LHS and RHS must be same. And your half job is done because, this is done. There's nothing to do here. And you just have to make these two equal. You have to make these two equal. Cool. So lambda by 2 has to be equal to 8. Lambda by 2 has to be equal to 8. You get this? Do you get this? Yes. So lambda by 2 has to be equal to 8. Lambda has to be 16. Easy, right? Easy, right? Do not do this mechanically. Just think about the question. What is given in the question? So what should we have? So how do we proceed with the information given in the question? Just think, right? The other way, the second method is to, if you do not like fractions, take 2 to the other side. Bring 2 to the other side. So we have 4x plus lambda equals 2 times 2x plus 8. This is the second way. Take 2 to the other side. So we have 4x plus lambda equal to 4x plus 16. Now, half the job is done here. You just need to have lambda equal to 16. Easy? Yes. Yes. Let's go to the next question. Question number 2. In the given equation, k is a constant if the equation has no solution. No solution. No solution. Let's see. So we have 1 by 3 times y minus k is equal to ky. 1 by 3 times y minus k is equal to ky. The equation has no solution. It says it has no solution, which means we are looking at a contradiction. Okay. We are looking at a contradiction. Okay. So think about this. Your coefficients of x on both sides must be same. Must be the same. And constants should be different. That's the idea. So that leads to a contradiction. Right? So as in the previous case, you can take 3 to the other side. As in the previous case, you can take 3 to the other side. So we have y minus k is equal to 3ky. Okay. Now the idea is coefficient of y on both sides must be the same, and the constants must be different, right? So what do we have? On the LHS, coefficient of y is 1, and coefficient of y on the RHS is 3k. And when you compare the constants, the constant on LHS is minus k, and constant on RHS is 0. Right? You understand these two conditions? You understand these two conditions? There are two conditions. One is just equate the coefficient of y. The coefficient of y is 3k here. The coefficient of y here is 1 here. So those two must be the same, and the constants should be different. So this is going to give me k is equal to 1 by 3, and this is going to give me k not equal to 0. So ultimately, these two conditions must be satisfied together. Of course, k is equal to 1 by 3 already satisfy k not equal to 0, because when k is 1 by 3, k is definitely not equal to 0. So our answer is k is equal to 1 by 3. Our answer is k is equal to 1 by 3. Our answer is k is equal to 1 by 3. Now let's do one more thing. Let's go back to the original question, substitute the value of k, and see that our case is true. Okay, our answer is correct. Let's see that. We are going to go back to the original question. We are going back to the original question. We are going back to the original question. So we have 1 by 3 into y minus k is equal to ky. And I'm going to go back and substitute the value of k here. Okay. So this is 1 by 3 into y minus 1 by 3 is equal to 1 by 3y. So what do we have here? We have 1 by 3y minus 1 by 9 is equal to 1 by 3y. Now what happens? What happens now? As we discussed, this 1 by 3 and 1 by 3 gets cancelled off, and you are left with minus 1 by 9 is equal to 0, which is wrong. Which is wrong. So no value of y can save this equation. No value of y can save this equation. That's the idea. Yes? Or you could have taken 3 to the other side. You have y minus k is equal to 3ky. Take y to the other side. Sorry, 3 to the other side. We have y minus k is equal to 3ky. And now you substitute the value of k. So y minus 1 by 3 is equal to 3 into 1 by 3y, which is y. So we have y minus 1 by 3 is equal to y. Again you see that y on both sides gets cancelled off, and you're left with minus 1 by 3 is equal to 0. Okay, so our answer is indeed right. Our answer is indeed right. You understand, right, why this equation cannot have a solution when k is equal to 1 by 3? Why this equation cannot have a solution when k is equal to 1 by 3? Because when k is equal to 1 by 3, the y terms gets cancelled, so y has no role. And afterwards, the constants are not equal, so that is a contradiction. And there is nothing you can do to save that equation or make that equation right or make both LHS and RHS equal. There is no way. Because y term is going away. You are left with the constants, and the constants are not equal. So there's no way you can match the LHS and RHS on both sides. I mean, match the LHS and RHS. That's right. Cool. Please tell me. Okay, we have more to solve this in this paper. I request you to have one more try at the paper, one more look at the sheet, because I think you have better idea now. Please have one more look at the sheet. Okay, and just what I'll take just one more minute, and I'll tell you one more method think about it for the next class. Okay. From this expression, find y in terms of k. Find y in terms of k. Please do this for the next class. For the next class, please find y in terms of k. And then figure out from that expression why k equal to 1 by 3 will give you no solution. The question is clear. Write y in terms of k. Write y in terms of k. And from that expression, figure out why k is equal to 1 by 3 will lead to no solution. Question is clear. Write y in terms of k. From this expression, figure out the value of k for no solution. Okay. So we'll meet in the next class. And Robin, if you are not able to access the recordings of the previous lectures, do get back to me on WhatsApp. In fact, I've been sharing all the previous lectures on WhatsApp group. Okay. Please do get back if you're not able to access it. All right, then see you in the next class. Please do spend some time working out math problems. Okay. Because, again, I've told you, we are not running a 100-meter race. We are running a marathon. So the consistency is the key here. Okay, you have to be consistent. You can't have ups and downs. All right, then. See you.